I'm very excited to be here for this panel this morning, the Global Energy Mix, Opportunities and Realities. And I was kind of thinking to myself last night, what is it that attracts me to this conversation? And I thought, I used to love the roller coaster as a kid. Do any of you out there love roller coasters? Yeah, I see some hands going up, some nods. Yeah, and you remember how you sort of like would chug along, chug, 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 and then whoosh, you'd go down, and you'd be going around corners and up, and then up, 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 and it almost like you're about to stop, and then you'd accelerate back down again. And I thought, yeah, that was good preparation for working on global energy issues. Because as we know, it's got a lot of ups and downs and a lot of curves. You don't really know where you're going until you get there. And there's a lot of acceleration. Those downhills are coming. I had the opportunity of spending a week earlier this month with Bloomberg New Energy Finance with Ethan Zindler, Director of Policy there. And a couple of facts really stuck with me that I think are useful to set this context for this morning's discussion. First, one that really hit me was the cost of PV solar has come down 75% in the last 4 years. That means it costs a quarter of what it cost to put in PV solar today as what it did in 2010. That's a phenomenal change. A second point that I thought was really fascinating out of the work that they do is looking at China. So we all think, China, they're putting in a new coal plant every week, and that's really part of the climate change issue and the carbon issue. Well, I wonder how many of us know that last year China didn't put in a new coal plant every week. Generally, 60% of their new electricity generation's from coal. Well, last year it was only 42%, and 56% was from renewables. First time that more than 50% of their new electricity from wind, solar, and hydro. So that's a big change. Electric vehicles, they're following the same trend as PV solar, where the cost of those lithium-ion batteries, which are really the cost of those expensive electric vehicles that we think can't really be part of the big transition with the cost, they're for the elite, but they've started that trend as well. It's gone down 1/3 in the last few years, and that trend is predicted to keep dropping as well. What's that going to do to our transportation and subsequently to our energy mix? And fossil fuels. Similarly, technological innovations there have made new shale oil, shale gas accessible that wasn't before. So we have energy independence on the horizon for the United States, our neighbor to the south. What's that going to do to the global energy mix? So all of these things are changing where the global energy conversation's at. And you add in a layer of the geopolitics. We look at what's going on in the Ukraine and Russia and how that brings up again the energy security conversation and the interest of countries to have their own energy. You look at the war on air pollution, the war on pollution that China declared earlier this month, and what that's going to do to this energy conversation. So all of that is background for an exciting conversation this morning. We have a very esteemed panel here that I'm excited to introduce. We'll start off with a question for everybody. They'll give us, have about 5 minutes for an answer there, and then I'll be moderating with some questions. We'll open the floor to you to have your chance to ask the panel questions. And if you're one of those Twitter people, the hashtag is #Globe2014, and feel free to tweet away. I did make sure that the panel had lots of coffee this morning and have encouraged them to not to interrupt, that was one of the rules. No interrupting, but to pile on to questions that are directed to each of them. So I think we're about to have a lively conversation. So I'll introduce our guests. We're starting with Marie-José Nadeau, who's the chair of the World Energy Council and also the Executive Vice President, Corporate Affairs and the Secretary General of Hydro-Québec. To her left is Ken Lueers, the president of ConocoPhillips Canada, a top 5 producer of oil and gas and one of the leading players operating in Alberta's oil sands. To his left, Jacques Besnainou, the director of General Fusion, which is working to develop the fastest, most practical, and lowest cost path to commercial fusion power. Next is Al Monaco, the president and CEO of Enbridge, a leading and diversified North American energy transportation, generation, and distribution company. And finally, Jules Kortenhorst, the CEO of Rocky Mountain Institute, which seeks to unlock market-based solutions to create a clean, prosperous, and secure energy future. And so we're going to kick off this morning with a big picture question for everybody to answer. And the question is, what do you see as the most profound shifts in the way we produce, transport, and use energy, and what new challenges and opportunities are these shifts opening up? And we'll start with Marie.
Thank you. Good morning, all. It's very interesting to be here in Vancouver this morning, and I thank Globe for the opportunity you're giving me to speak on behalf of the World Energy Council and to give you a global perspective on how profound changes in the energy sector are occurring. We're all aware of the effect of rising U.S. oil and gas production on North America itself. But beyond this continent, there have been multiple effects leading to profound changes in energy trade flows. We see crude oil West and North Africa being redirected to the Far East, with the Middle East oil producers being forced to take exceptional measures, such as setting up their own storage hubs in Asia to protect their market share. But the changes are not limited to oil and gas. Rising hydrocarbon production in the US has displaced coal to Europe, coal that had been previously burnt in America. This decrease of coal prices in Europe compared to gas prices has led to the mothballing of combined cycle power plants, recent ones and modern ones, and a commensurate increase in coal burning. In turn, this has pushed GHG emissions up, the opposite of what Europe has been trying to achieve. All of a sudden, Europe is not as clean anymore. The second big change is the move away from nuclear energy following the accident at the Fukushima power plant in Japan. This has prompted many governments to reconsider their position towards nuclear energy. While today Japan is looking at bringing back their nuclear plants in service, mostly for security, energy security reasons, Germany stands by its decision to phase out nuclear power by 2022. Some consider this a brave move. Others believe Germany is jeopardizing its strong economic position. But everyone is watching with great curiosity as to what will happen. The third big change we're looking at are renewables, which have made the global energy picture much more complex. Again, let's look at what's happening in Europe. Some European countries have spent heavily to subsidize the development of renewable sources of energy, such as wind and solar, in order to cut carbon emissions and increase energy security. The combination of the added capacity of the renewables and the economic downturn has led the system to be in excess capacity, with rebound effects on grid interconnected countries. And as renewable, low carbon energy accounts for an even greater share of production, it is shouldering aside conventional plants that provide base load power and threatening to destabilize the grid. And then there are the unexpected events. You've referred to it, Merran, such as the crisis in the Ukraine and around the Crimea Peninsula. The political tensions going on in Europe and with one of Europe's key energy supplier, Russia, have added a new layer of complexity. At this point in time, to be very blunt, Europe would run out of gas within a few months if the Russian gas exports were interrupted. There are no short-term viable options to replace 30% of Russian gas imports. True. There are public discussions in the US about lifting the ban on exports and allowing for sales of gas to Europe. but that would take well over a year to materialize at the very least. So on one hand, we have an increased and continuously increasing complexity of the energy system, and on the other hand, we have an increased policy and regulatory complexity. And the two are very much linked to one another. Against this background, creating a policy framework that supports secure, affordable, and environmentally sensitive energy, a sustainable energy system, is one of the most important challenges governments and industry are facing today. All national energy systems are based on finding the right balance among these three elements. Rising energy prices, increasing concerns about carbon emissions, and concerns about long-term energy mix and security mean that many countries are re-evaluating their energy policies. To conclude, the pressure on energy systems is immense, as energy is one of the most critical issues for governments, businesses, and civil society, and everyone wants to have a say in it. Thank you.
Thanks. And to you, Ken.
Well, thank you very much. I echo the comment from the fact that it's a huge privilege and opportunity to get today's speech to be able to deliver some thoughts to you. And excuse me, as I think about the uncertainty of the future of energy, what I wanted to go and communicate is the fact that I think the future is certain. And the future is certain in the sense that we do need all forms of energy. When we take a look at the International Energy Agency prediction of 35% demand growth in energy by 2035, we need to go and fulfill that demand, and it comes from all sorts of energy. And the reason I say this and why hydrocarbons are there, because there are profound shifts. There are profound shifts as it relates to innovation, technology, and collaboration, how we all work together. And at the same time, what that has allowed is us to go and connect into these challenged reservoirs, these very unconventional reservoirs around the world. If I think back to almost 30 years ago when I started in this industry, the technology revolution that has occurred has actually supercharged our ability to go and extract these resources that Mother Nature afforded us that we never ever thought was possible. At one time, these rocks had absolutely no value to us other than what we were doing for study purposes. And now we're going and utilizing those resources into valuable consumer goods. At the same time with all of this, the innovations and efficiencies that have been driven in the industry continue to go and help improve our environmental performance. It allows for environmental protection and conservation, and it allows communities to go and become much more vibrant. It's helping take people out of poverty and into a much better social well-being. We've invested heavily into a variety of different technologies as it relates to the oil sands in particular, and I'll talk to some of those. These take time, they take a lot of money, and they take a lot of collaboration to go and implement, not only to go and determine what those key technologies are, but also how do we go and implement them in a thoughtful way such that we go and get meaningful results that can be game changers out there. In the steam-assisted gravity drainage of production in our oil sands, which we're only an in-situ producer, we are piloting a technique where we inject lighter hydrocarbons into the reservoir. And this reduces our need for steam. And at the same time, with the reduced need for steam, the improved production performance, we produce less greenhouse gases. And this is a 15 to 35% reduction in GHG emissions that we have gone and piloted and tested and believe are possible. At the same time, with the once-through steam generators that go and burn natural gas in order to go and create the steam, we've been able to go and take waste heat from there, run it through a gas turbine, and generate electricity. We also have alternative well configurations, tremendous amount of technology. When you think 300 to 400 meters below the surface of the earth, we can go out a kilometer and a half, and hit a target the size of roughly my hands here, and be able to go and drive something so incredible that it is not left, to be thought that this is a rough and tough industry. This is a high-tech industry in which we produce oil and gas as a means to go and generate profits. These technologies where we go, and now we started drilling these fishbone wells that come off of there, are going and have the potential to open up 3 times the amount of reservoir that we conventionally thought was possible. So it has a huge impact in terms of our land footprint. It has been our company's efforts in the Oil Sands Leadership Initiative, which is a consortium of 5 different companies a few years back that wanted to go and improve our environmental performance. That has transformed itself a couple of years ago into the Canadian Oil Sands Innovation Alliance. 13 companies that represent 90% of the oil sands production that are sharing 560 different and distinct technologies that cost over $900 million to develop. We have the structure in place now that allows us the freedom to go and share these technologies amongst ourselves that we're able to go and implement. Now the large task is, okay, what one of those are going to be suitable for our projects to go and make game-changing technology efforts come to realization. And this is all about industry collaboration. It has nothing to do with competition. When it comes to health, safety, and environment, there is no competitive advantage in this world. It is not appropriate to go and compete in that space. It is important to collaborate and share. And that brings us to the natural gas industry. If I think about what we were going and trying to accomplish over the last 4 years, from 2008 to 2012, 4 years, the natural gas industry has been in the doldrums. Very, very poor profitability, and we're in the red for many, many years. At that same time, we've driven efficiency in that system. And I'll give you an example. At our Elmworth gas plant, our largest gas plant we have here in Canada, we went and instituted a waste heat exchanger. That waste heat exchanger went and reduced the consumption of natural gas by 50,000 cubic meters per day, which equates to about 34,000 tons per year of greenhouse gas emissions. So we went and said, okay, well, that's possible. In addition to, we have a number of smaller opportunities, and we implement them across 400 different facilities in our business. And over that 4-year time frame, we reduced our greenhouse gas emissions by 1 million tons, or we took 67,000 cars off the road. So I just want to illustrate the fact that there's tremendous amount of effort, innovation, collaboration, and technology that's going into the business to make sure that we have the balance of the environment, the economics, and our social well-being of the communities in which we operate in. Thank you very much.
Great. Thanks a lot, Ken. Over to you, Jacques.
Yeah, thank you, Merran. And good morning, everybody. So as you can guess, my name is Jacques, and I came from Paris, but it was 20 years ago, and I came to New Jersey. So I got a slight New Jersey accent. So I'm going to speak slowly. I want to start with a story, and we'll answer your question. Last week, I was invited by the White House. I live in Washington, D.C., to the launch of what they call the Climate Data Initiative. What it is, basically, it's the U.S. administration is going to release data, GIS data, from satellites, from NASA and the USGS to the public in order to cope with the rise of sea level. So I was very happy because I think I commend the administration to help communities. But basically, I was sitting there with 100 people, and we were talking about losing in 50 years New Orleans, Florida, the Everglades, and closer to my heart, because I live there, actually the Chesapeake Bay. Okay, so I said to myself, okay, that's great. We need to cope with that. But it's not a fait accompli, like I say in my New Jersey English, fait accompli. For me, we need to fight it, you know. We need to, and we're 50 years ahead of us, you know, to make sure that our kids are going to enjoy the Chesapeake Bay, and we're not going to lose country in the middle of the Pacific Ocean. So I come back to my passion. I come back to nuclear energy, and I'm happy to discuss anything about what happened in the last few years. But I really believe, I still believe that nuclear energy is great. Nuclear energy is a dense energy. It's available 24/7. That means that when you flip the switch, you get electricity. It's available 24 hours, 7 days a week. And also, it was not designed for it, but it's carbon-free. So I asked myself, So if I want to continue with nuclear energy, fission is great, but why don't we accelerate fusion? And I think the most profound shift that is happening right now is that fusion is going to be a reality. For a long time, I thought that I will have to pass it to my children. I mean, I will never see fusion. But look at, you have ITER in France. It's a large program. And actually, 5 or 6 different countries are working together to bring fusion of 500 megawatt reactors in the south of France. By the way, I invite you to go. It's beautiful. Provence. I think this is the reason why they're located over there, actually. And also, you have here, closer to home, it's in California, you have NIF, the National Ignition Facility, where they look at laser fusion, and they're making very good progress. Actually, they announced actually almost net gain, I think it was a month ago. And you have us. We are, I would say, the Wright brothers of fusion. We are here in Vancouver, local, Canadian company, funded by private investors, and we are making enormous amount of progress. So I think the shift you're talking about is that we're going to fusion, all of us, during our lifetime. Thank you.
Thank you, Jacques. You got some fans in the crowd.
Jacques, you've never been to New Jersey, have you?
My daughter, I moved to New Jersey in '93, and I have a daughter from New Jersey.
Sure,
She's now a beautiful 20 years old.
Sure you do. Maybe I'll make a few comments on the trends that we see, and then some discussion around opportunities and challenges.
Great.
So on the consumption side, maybe we'll start with that one, or demand. It's pretty clear to us that we're going to see anywhere from a 35 to 50% increase in consumption globally by 2040. That's hard to get away from, and that's driven mostly, as everyone knows, by non-OECD growth. The thing that's unusual, and we're starting to see, is really a decoupling of the growth in GDP versus the growth in energy. And I think that's a function of the stricter standards and improving efficiency that we're seeing. So that's basically the consumption side. On the supply side, dramatic changes there, I think, as everyone knows. We've basically moved from scarcity to abundance. And that comes through, as Ken said, through unlocking of unconventional reserves. What's interesting is we've also moved from an import-based North American continent to one that's focused on exports. And all you have to do is look at the LNG situation. You've got roughly 9 BCF of LNG projects per day, gas projects on the go right now, and improved 28 BCF per day worth of projects in the proposal phase. In Canada, 15 to 25 BCF per day potential exports. So the North American continent is now refocusing on exports. This issue is, as you've seen in the last few weeks, even more important as we look at some of the geopolitical issues coming to the fore. The thing about supply is we see a massive shift in the mix of supply, and I think of it as one of these all-of-the-above scenarios. I think oil is going to slow its pace of growth, but will still be there. Coal will increase, but then flatten out as we move forward. Gas and renewables actually see the largest level of supply growth out of all the sources of energy, anywhere from 2 to 3% annually into the future. Renewables increase so dramatically, as was mentioned, because of the sharp improvement in the overall technology, particularly with solar and to a lesser extent wind, although still there. The issues that we have on the supply side, there's 2 or 3. Number one is how sustainable is this major uptick in shale? Can we do it cost effectively? I think if you look at the cost curve for shale, there's a lot of projects in North America, along with the oil sands, that are pretty high on that cost curve. So that's one thing I think we have to watch very carefully. And of course, then there's the implication of climate change policies, which, if you look at the various scenarios, it's really uncertain as to how much of an impact those climate change policies we're going to have. Last topic on this general shift is, if you look at the transportation infrastructure in North America, which is what we're involved with for energy, you're going to see massive investments required to move energy from supply sources, many of which are new, to markets. First in North America, and then, as I said earlier, then to export markets. If you think about the grid and the flow of energy in North America, basically it's gone from one that's driven by imports with all the flow moving to the center of the continent. Now the whole game is to move that supply to coastal markets and then obviously next to exports. The one thing about our infrastructure that's quite interesting is we are using existing rights of way. We're using existing pipelines, reversing them, converting them. So it's quite positive in my view in that we're using what we have as much as we can today. That's a function partly of the increased focus and opposition to these projects. So just a couple of comments on challenges and opportunities. The number one challenge in my view is this dichotomy between the need for energy and the fact that we all want to move to a lower carbon intensive environment. And my view is that we're going to see this transition happen, but it's going to be at a relatively slower pace than perhaps we'd like to see in the future. We as a company, I think, are a good example of the transition. We initially started as an oil pipeline company. We now have significant investments in natural gas, electricity transmission, and more recently, I guess, over the last decade, substantial renewable investments. So we have a perspective, I think, as to the entire global picture of where the energy supply-demand is going. The next challenge and some opportunities here relates to safety and environmental stewardship. The reality is that whereas we as energy companies used to focus on individuals that were directly affected, the issues now are more national in scope, and that's a lot to do with how people communicate today. So when we talk about energy, we're talking about national issues, and that's how we see it happening today. The economic benefits of a project are not enough today in order to get public support. You need to have an equal focus on sustainability. So it's kind of like two sides of the same coin, environmental leadership as well as leadership in safety. We are putting our money where our mouth is on this. We have a neutral footprint program at our company. Basically, we replace a tree for every tree that we disturb along the right-of-way. We replace an acre for every acre we use up. And we replace a kilowatt of energy that we consume in our operations with a kilowatt of renewable power. We've made somewhere in the order of $3.5 billion investments into renewables. This is over the 10 years I refer to. Before renewables were fashionable, actually we were right into it way back. We're reducing our own emissions. We're not a large emitter, but obviously the entire value chain has to be focused on reducing emissions, 21% reduction since 1990 in our case. And then finally, we have a large gas distribution utility, the largest in Canada, and our demand-side management programs that encourage people to reduce consumption have been very effective, somewhere in the order of 8 billion cubic meters of gas and 15 million tons of CO2 saved. To put that in context, that's like removing 3 million cars off the road in a year and 2.5 million homes heated in terms of the volume that we're saving. So the general thesis is sustainability is key to where we go in the future. That is going to happen at a gradual pace, we think, but nevertheless very important.
Great, thank you, Al. And finally to you, Jules.
Thank you. Good morning, everyone. Lots has been said already, and I don't want to repeat many of the very useful points that were brought up. But there are 2 points I want to highlight. The first one is the importance of greenhouse gas emissions and sustainability. And second, and partly linked to that, the acceleration of new technologies. So let me first give you my personal conviction on the issue of greenhouse gas emissions. The IPCC, the International Panel on Climate Change, the largest and most professional peer-reviewed mechanism of science that mankind has ever put together, came out with its latest report in the fall of last year, pointing out that as mankind, we can continue at the current pace of greenhouse gas emissions for another 10 years, and then really should reduce our emissions to zero. 10 years of current greenhouse gas emissions, and then down to zero. In order for us to have a 50-50 chance to limit global warming to 2 degrees, which by many scientists' opinion is a critical threshold. Scientists are telling us there is no longer any doubt about the urgency and enormity of the problem. And that context is starting to filter through in society in ways that in some instances in the energy scene and in some instances in the political scene is not yet part of the reality. In the run-up to Copenhagen 5 years ago, we all thought that there would be a global deal on greenhouse gas emissions, that governments would declare policy, and that we would solve the problem that way. Clearly, that did not work. And I don't expect that next year in Paris there will be a legally binding agreement where nations will somehow commit to the policies necessary to make the reductions in emissions. But at the same time, business leaders and consumers are starting to shift. We've recently done some work with a Fortune 50 company that basically has made a public commitment to shift to 100% renewables. I don't think when the CEO made that commitment, he had completely verified that with his procurement department, and he also did not set an exact date on it. But anyway, their procurement people were sitting with their hands in their hair saying like, okay, how do we do this now and when can we do this? And they were pleasantly surprised to find that they could do this right now without increasing their financial burden for making the shift to renewables. And that if they tweaked the decision-making on capital allocation a little bit, and if they looked a little bit more widely at the tools available to them, that transition could be completed by 2020. And this company is going to go right ahead and do this. This is one of a number of Fortune 50 companies that is talking to us about this. And wholesale switches of very large pools of demand to renewables will continue to drive the transition. In addition to that corporate leadership, I also think that what we're seeing is tremendous leadership from developing countries. I'm glad you brought up the point of China. We are still living with yesterday's news. Every week a new coal plant in China. Those of you who have been there recently realize that the Chinese government is breathing the same air that you are breathing as a visitor, and has therefore come to the conclusion that that is no longer a feasible pathway. And therefore, China's commitment to deploying at massive scale renewables is unrivaled. Just last year, as you said, China produced more electricity from new renewables capacity than they produced from fossil fuels. And they put in 1 year, more solar capacity than the cumulative solar installed in the United States over the last 25 years. In 1 year. So that gets me to my second point, and that is that the technology revolution is accelerating. And what you consistently see is that mankind overestimates the impact of new technologies in the short run, and then underestimates the impact of new technologies over the long run. We find it very hard to stare into the long-distance future and imagine what is going to be out there. We can sort of deal with the next couple of years, and we're a little bit optimistic, but we find it very hard to look over the horizon. Our founding father, Amory Lovins, who spoke here earlier at the conference, has consistently been able to do that and has predicted a future that now seems to be coming to reality. The reduction in prices of solar, storage, as a result of that, electric vehicles, to a lesser extent wind, demand management technologies, is all rapidly accelerating, way beyond what we could predict. The 75% reduction in solar costs was not in anybody's forecast. And of course, some of that was a short-term glut of supply, with new capacity coming on stream in China, but a lot of it is structural improvements across the value chain of solar. which we're only just now starting to see. So we forecast that that trend continues. Maybe not exactly at the same pace as the last 3 years, but certainly at order of magnitude 10, 15, 20% per year for the foreseeable future. And what that does is it puts distributed generation of solar and storage at the fingertips of consumers, big and large, across the United States over the next 10 years at prices that are competitive to their delivered electricity prices from their utilities. What that means is that people will have the option to cut the cord. And the same trend, we believe, is happening in other technologies. There's one more point I want to make about the scaling of new technologies, and then I'll wrap up. And that is that those new technologies get implemented much faster. You can make a decision to install solar panels in your roof around the kitchen table at home. The permitting process is a matter of weeks, and it can be done by the end of the month. Compare that to the processes that some of my colleagues on the panel here have to go through to install their new capacities. Years and years and years of planning, approvals, permitting. So what we see is a rapid acceleration of the scaling mechanisms in the renewable energy industry that will dramatically drive the speed at which capacity is coming into the market and the reduction in cost. Thank you.
Great, thank you. So now I've got a few questions here for the panel, and I'm hoping you can keep the answers short to about a minute or so, because I've got a lot of questions and I'm sure there's more in the audience here. So I'm going to start with you, Jules. What in your mind is the world's largest untapped energy reserve?
Well, the largest untapped energy reserve, and speaking in the words of our founding father, Amory Lovins, would probably be the negawatts, the negative energy. If you look at the potential of energy savings that is still out there, whether it is fossil fuel-based energy from oil or electricity-based energy, hands down the largest resource we have at our fingertips is reducing energy demand. And that holds true for both automotive and for electricity. I was recently talking to a CEO of one of the largest utilities in the United States, and he said, well, we haven't seen any growth in demand. In fact, the demand has been falling since 2007, but you know, it's going to change. My forecasters tell me by 2014, electricity demand will pick up again. Now, I've run a few small clean tech companies, and my instinct is that if your planners tell you that the increase is in 2014, the reality really is that they don't think there's ever going to be an increase anymore. And I think that along the same lines, 10 years ago we talked about peak oil meaning peak supply. There are now serious forecasters in the oil scene that say we will face peak demand in the next 10 years on a global scale. We are already starting to see peak demand in developed markets, but we're holding on to this idea that Asia, and specifically China, is going to continue to rev up demand. But China is not going to go the path of Western civilizations. China is going to go a different way, particularly when it comes to electric transportation. And I don't think that sustained increases in demand for oil from China are going to make up for falling demand in the rest of the world.
Okay. So now on to the subject that Jules brought up around climate change. The science is very clear that we can't continue extracting carbon-based energy at the existing rates and also avoid the worst impacts of climate disruption. So against this reality, what does responsible energy development look like? And maybe you can start, Ken, and maybe you could have some comments as well, Marie-José.
Okay, sure. Happy to. Excuse me. Really 3 parts to the answer. Number one, responsible energy development has to be safe. That is a cornerstone of it, not only from a personal point of view, but from a process point of view. But we also need reliable and affordable energy. If it's intermittent, that doesn't work very well for any consumers in any way, shape, or form. If it's not affordable, then it goes and it competes with food, clothing, shelter. It's something that is fundamental to our economic, environmental, and social well-being. So when I go and look at it, I think, okay, we can go and drive on those cornerstones, how we go and responsibly develop the energy resources. It's through the research, it's through the technology deployment, it's through the energy efficiency. And when you see communities that have actually gone and being able to participate in these economic developments and how they've worked themselves to far lesser degrees of poverty, economic benefit, and the more educated, more financially stable you are, the more care and concern you have for the environment, it all goes part and parcel. So we like to go and absolutely be integrated with the community, have the respect for the individuals, their property rights, and to go and support them in building a much better life. I think the second piece is a very strong and efficient regulatory system. We do have that here in Canada. I'm very proud of our regulatory system. We continue to drive efficiencies in there, and efficiency isn't less regulation. Efficiency is going and making sure that it's strong regulation, that it's very well known, and how to go and make sure that we develop our resources. And the third part is what we call responsible energy development, and that's just sustainable development in our language. It's ensuring that we have economic growth, that we go and maintain the health of the environment, and that we go and generate vibrant communities all in harmony. And so what we do to go and try to achieve this is we look at the issues and the risks. We go and we take a look, what are those different options that we have to go and address them? And then, of course, we have to make a choice, right? There's no other way. We implement those plans, then we track that performance, report it out. And we do this in such a way that we report it out publicly. We have a sustainable development portal that we've had for a number of years. And when it was back in 2007, we were making some of these commitments. It was kind of like, I have no idea how to go and get there. But we went and we set those out. And I think there was about 45 at the time. And we were able to go and achieve so many of them. And they've went and turned into base business for us. And that's how we continuously improve. So that's how I view the future.
Okay.
Thank you. Well, one of the things the World Energy Council does is we publish scenarios. And we've just issued last October our scenarios for 2050 report. And one of the conclusions of this major work that we've been doing for the last years is the following. In the best cases, we will see a near doubling of GHG emissions by 2050. At worst, GHG emissions could increase by over fourfold. Well, that being said, your question is, how do we cope with this major challenge? Well, of course, there are the renewables, large-scale hydro, but also I think, and Jacques will be happy to hear me say that, I think we'll see the resurgence of nuclear, at least in the midterm, maybe not on the short term, but in the midterm, it will be part of the portfolio of solutions. He thanks me. The other thing is that we will, the untapped resource is innovation, RD&D, CCS, CCUS. This is a promising initiative. It's been proven. We need the regulatory framework to sustain this. We will need CCS and CCUS. And then Jules will agree with me, energy conservation and energy efficiency are part of the solution. That's how I would sum it up.
Okay, thanks.
Can I jump in?
Absolutely.
I just would like to make sure that we have a broad consideration of this question, because we're talking about 2050. And I'm looking around this panel, and to be honest with you, most of us are going to be a bit creaky and old by that time, right? So I'd like to look in the audience. It's a bit difficult with the lights, but how many people here are under 25? I see 2 or 3 hands. Good. Well, I have a few of you around the dinner table at home, and we sometimes discuss the choice that you were referring to. The choice about what is truly responsible development. And generally, the vote of the under 25s is slightly different than here at the podium. Because as I just said, the IPCC has calculated that we can continue to emit about 500 gigatons of CO2. Now, that represents about 20% of the balance sheets of your company and some of your members in general, it represents 20% of the fossil fuel reserves on the balance sheets of large fossil fuel companies around the world. How do we come to grips with the fact that responsible development, according to the scientists around the world, means that we have to take an 80% write-off on the stocks of coal, oil, and natural gas currently on the balance sheets, therefore proven on the balance sheets of fossil fuel companies. That's the real challenge, and we're avoiding that discussion. But that really ought to be the discussion, because if there were more of you young folk on this podium, that would be the discussion we would be having.
Well, that's great. That's a good lead into a question for Jacques, because you represent a very carbon neutral potential energy. There's a high level of skepticism around companies like yours trying to invent something new, and that kind of comes with the territory.
Of course.
If you're going to be way out in front of everyone else and in front of what real possibility is. So many would say you're pursuing the ultimate long shot. How do you respond to that?
Yeah, I think it's a very fair question, and I guess skepticism is very good, especially in the world of science. So I must say, and I was a skeptic as well. You know, I'm a man from fission. I mean, I was at AREVA for more than 10 years. And when I got the phone call from my friends in Vancouver saying that, would you be considering going on the board of General Fusion, I said, it's a startup. You know, talking about fusion, there is an oxymoron here, you know. It doesn't work this way. And, but I'm curious. So I said, yeah, I love Vancouver. So I said, why don't I come? And I came, and I met everybody at General Fusion. It's a small company, 60 people, but they've been doing this for 10 years. And what they have done in 10 years, actually they've done in 10 years what everybody else have done in 50 years. I mean, slowly they are moving very, very fast. I mean, and again, I'm not asking you to believe me. I mean, it's right around the corner. Just take the SkyTrain. It's in Burnaby. And so you can see there is a machine over there. We're doing shots, and we're making progress every day. And so I'm saying here, I found the Wright brother of fusion. Remember the Wright brothers? I mean, they beat the US government inventing flying. I think we're going to beat the US government again. And so just to put that in perspective, I wanted to show you, and this is the last thing about what we're doing here. And by the way, I wanted to answer the most untapped resource. I agree with you, it's megawatt, but also it's seawater. Because if we're successful, I mean, the fuel for fusion, this is seawater. So I wanted to take the example of this. I don't know if you remember, it's called the Moore's law of computing power, the law of Moore's law. And I think Mr. Moore said about 50 years ago that we are going to double every year computing power. Actually, here, there is as much computing power that it was 25 years ago when I was in school with a Cray 1 or 2. I mean, people don't remember here, but so there is the same thing in fusion. If you look at fusion in a very objective manner and you look at the amount of fusion power control, I mean, being made since we started actually seriously doing fusion in the 70s, I mean, we are doubling power every year. So I'm very confident, and please come and see for yourself, that in the next 5 to 10 years, we're going to crack it. And I hope I will be able to see it and put some electrons from fusion on the grid.
Okay. You've got some fans. So your new school, but petroleum production and transport companies, you're often considered old school, you know? And so I'm wondering, Al, what you can say, what are you doing to position yourself technologically to sustain your business? You know, moving past the petroleum transport issues, how do you become new school?
Right. So excellent question, because I think there is a perception that our industry is a low-tech, seat-of-the-pants, antiquated business that doesn't focus on technology. The reality is actually quite different. I think the key thing first is why why are we focused on technology in our business? And I think today you really do need to be at the forefront to be competitive. I think secondly, your customers are demanding it, whether it's upstream of us or downstream of us. These are very significant value chains with billions of dollars being invested, so your customers are requiring you to be at the technological leading edge. And then thirdly, the public is insisting on it, that we move forward with technology within the context of what we do today. Just a couple of examples from our side of the business. Pipe design is a good one. We use the same technology that NASA uses to map the surface of Mars in order to find the best locations to route our projects. We use high-strength steel and very advanced coatings to make sure the pipe is protected. Inspection of the lines. These are the tools that we run inside the line. We're now using something very similar to medical imaging technology to ensure that we're inspecting every millimeter of the pipe internally from a number of different angles. Operations control. We can look at our entire North American infrastructure grid and monitor it second by second to assess whether or not anything's going amiss. Certainly, we're moving into supporting unproven concepts of investments. And these are things that are not contributing to the bottom line. Give you a couple of examples. Ultra-sensitive acoustic sensors that we move into the line while the product's flowing to ensure that we can pick up the very smallest of incidents. We add pigments to coatings and paint to pick up H2S that could be within the facility. But I think the future, in terms of moving to lower CO2 intensity, as I said before, we are a very large generator of solar power and wind power. For us, that's about 1,800 megawatts of capacity. But we're looking at newer technologies as well in that area, smaller solar panels, low-velocity wind turbines, looking at geothermal fuel cells. So this is, I guess maybe to go to Jules' earlier point, this is a way we feel that we need to transition our business over the longer term to a lower carbon-intensive economy. I don't think it's going to happen within the next 10 years. That's simply the reality of where we are on the consumption side and the supply mix that we foresee.
Okay. So one thing that you brought up, Jules, was the age issue. Another one that Marie-José and I were talking about in the back room here was the gender issue and the fact that we're 51% of the population, we females, and there's rarely anywhere close to 51% of the people in the meetings around energy and the conferences and in the decision-making roles are women. So I'm wondering if you've got any thoughts on that. What role, if any, does gender play in energy politics and in energy conflicts?
Well, energy politics and energy conflicts, that's an interesting way to put it. I wouldn't want to tackle this issue with a view of the fact that the strong male presence in high-level meetings would suggest that this would lead to a conflict. But I rather see it as a missed opportunities. Because our sector is so demanding. The energy sector is so demanding. We're undergoing major changes. We've been referring to the changes since the early moments of this panel. And it's just counterintuitive that we would shy away from half the talent, half the skills. And we're talking about the gender agenda, but the same could be said about the younger professional being active on board. We're all talking about tomorrow's energy. And the younger generation, men and women, have a word to say in this debate and in the solutions that we'll bring forward. So I've been very active at the international level promoting this view that we have to bring on board more women and more young professionals. I've been, the only woman on the World Energy Council's board for 15 years, The board has been appointed for the next 3 years. I'll still be the only woman there for the next 3 years. So I really do feel strongly the responsibility to push this agenda forward and to make sure that when my job is done, there will be a pool of talented women that will be able to come on board and follow up.
Okay, so this is my last question before we open it to all of you. I have a lot of questions left to ask, but I think we're just about going to run out of time, and I want to make sure that if you've got questions out there, you can put them forward. So this is about transportation. We haven't talked too much about transportation. A great deal of carbon energy is currently used for transportation. What do you see as key emerging trends in mobility? And how are they going to impact the demand for traditional carbon fuels and for renewables? And I'll just throw the floor open to anybody who wants to take a crack at that one.
Well,
No, go ahead.
okay, I'll go first. I think the challenge here is what can we do immediately to reduce emissions on the transportation side, as you point out. I think the most available and immediate opportunity is the use of natural gas for transportation. It's abundant, it's lower cost, relatively speaking, cleaner than other forms, especially against diesel. I think this is an excellent application for large fleet vehicles in North America. 25% lower in GHGs than diesel, as I mentioned, with no atmospheric contaminants. We actually have one of the largest natural gas vehicle fleets in the country at 600. We have refueling stations as part of the infrastructure. The challenge with gas, of course, for transportation is the lack, so far anyway, of an abundance of these refueling stations. There's also the opportunity to establish LNG corridors, as is being done now by an affiliate of ours, GazMet, from the Ontario to Quebec corridor. So I think natural gas is something that we can get at right away.
I would think that if you want to look to the future of transport, you should look in two places. First, you should go look at the number of patents that have been filed and the amount of venture capital that has been invested over the last 5 years in the area of battery storage. And the increase in patents and the capital commitments by VCs over the last 5 years has dramatically ramped up, and we're starting to see the benefits of this. And I forecast that in the next 5 years, the shift in cost on batteries will be similar to what we've seen in the last 5 years on solar. And that will dramatically change how we look at electric vehicles. Because right now that Tesla is just about the sexiest car on the road, right? But it's just totally unaffordable, at least for somebody on an NGO salary. But if we could get that car for half the price, then it suddenly becomes a very attractive vehicle. And that's going to happen in the next 5 years.
You work for an NGO that must pay pretty well if you could afford one at half price.
The second thing, then it would be a demonstration model, right?
That's very good.
The second thing would be to go look in China. The urban pollution in China is the biggest issue that the Chinese Communist Party faces at the moment. And it is a threat to the stability of the country. And it is something that affects everyone there. So what is going to happen is that China will turn every lever. And China is still going to build about 2/3 of their automotive production capacity. So they still have a greenfield opportunity to build the cars of the future. Not the cars of the past, but the cars of the future. And those cars are going to be lightweight. They're going to be alternative drivetrain, electricity. They're going to be smaller. And as China develops that segment of the automotive industry, it will massively shift the whole industry around the world. So I think two major discontinuities, China and batteries.
Great.
Maybe I could just jump in here. Hydro-Québec, which is my full-time job, has been working very intensively on the battery for EVs. And we've been partnering with Chinese and Indian companies, corporations, doing major R&D in our facilities in Montreal. But what we see an increase in the EV coming into the mix of transportation. But you're right, the cost of batteries must come down. There are still major investments in infrastructures to be made, and we need the regulatory frameworks to support that. And we also need the investments in smart grids. The technology exists, but we do need the investments in smart grids so that we can use the storage capacity of the batteries. So the technology is there. We still have to work on it, improve it, commercialize it. But I mean, this can be rather short to midterm. But we will need investments and regulatory frameworks.
Okay. So, do we have mics out in the audience there? If there's any questions, does anyone have any questions?
Very good question on geothermal. I think it's one of those areas that Mother Nature has afforded us where we can go and we should extract that opportunity. You know, Iceland is a key example. Hydro in Ontario, Quebec, tremendous opportunities is you know, compare and contrast. On the geothermal side, I think what it comes down to is we've been rich in resources. Elle mentioned it around the natural gas side, how inexpensive it has been. It's proven reliable technology, and that is what, in my view, has driven it in history so far. I see no issue in going, and where those opportunities exist, I think we should capture them and utilize those resources.
We have some, We have some experience in this area as well. We have a geothermal project in the United States, and very efficient, and I would say it's in its preliminary phases, though. The issue you have with geothermal is the location of the resource. And generally, that's disconnected or long distances away from major distribution centers. And that comes with additional long-haul electricity transmission costs. And this, I'm going to use as an opportunity to come back to what Jules said around this issue around getting off of fossil fuels and into renewables at a much faster pace. The reality of the situation is that if you look at where the supply of renewables are in North America, they're generally a long distance away from the major load centers. That means you need a lot of transmission, and these are long linear projects that if you think building pipelines are tough, that comes with a lot of difficulty as well. I think the renewable generation makes a lot of sense when you're talking about relatively low amounts of the total generation capacity. Once you start getting up to 20% of the grid, you start to see a lot of instability, and that has to do with the intermittency of renewables. The costs are another factor around intermittency and building backup power. That's a factor. The stranded cost of our existing generation is obviously another one. So I guess those are my comments on renewables.
I gotta jump in on the intermittency issue.
I thought you might.
This is the single most consistent fairy tale that is being spread around. We cannot do it because intermittency means that you'll have brownouts. It can't work. You know what one of the most reliable electricity grids in the world is? Denmark. You know how much power Denmark produced from renewables last year? 45% QED. It's just not true. We have all the technologies. It is being done. It can easily be handled. Yes, it requires some smart technologies, IT coupled to the grid, but there is no issue. And the fact that we keep hearing that as you get over 20%, you're going to get brownouts, and it's going to get impossible, and it's unstable, and it's difficult, it's just completely baloney.
Okay.
Jules, if you,
Yeah, go ahead.
no, go ahead.
No,
That's
no,
fine.
you go ahead.
If you look at the target of 80% for renewables that we often hear about, the practicalities of getting to 80% are impossible. For China, for the United States, it's just not going to happen.
Not factually correct.
Anytime soon.
That's another question. But can it be done? Time and again, it has been proven that this can be done. National Renewable Energy Lab in Boulder, Colorado. The European Climate Foundation Roadmap 2050 study, and I can go on and on, have done detailed studies separating supply and demand in 15-minute intervals, looking at various alternatives of mixes of renewable energy, and 80% is both technically feasible and commercially affordable over the course of the next 20, 30 years.
The question is, Jules, by what time frame? And we're coming from a perspective of being a renewables investor. So that's where we come from. And our view is that, yes, we may be able to get there over time, but it's not going to happen before 2050 or potentially even later. That is the reality of the situation when you look at the amount of energy we need to power the economic growth. We've got population growth, we've got urbanization, and we've got standard of living improvements. That's going to generate a massive increase in demand for energy that simply cannot be met practically in the short term for the next 2 to 3 decades with renewable power. It's not going to happen. I'm sorry.
So we have some difference of opinion. To you, sir.
I did go and make some comments earlier on the responsible energy development. It also has a social component that's very, very important in it. If we just kind of take a step back a little bit, the goods that we're wearing, the watch band, the stitching, in my suit, it all comes from a petroleum-based product. The tabletop here, and so when we talk about responsible energy development, we know that we do have a temporal impact to the environment, but we need to lay the environment back to what it was. And I'll give you just a unique example because I know we want to go and get to more questions. Is in the oil sands, we have a program called Faster Forests. So when we go and disturb the land, we reclaim it back. But we don't go and plant the cheapest trees or what grows the fastest. We put back the native species, and the land is contoured back to the same condition it was. To me, that's a great example of responsible energy development. We avoid line of sight for predation when it comes to wildlife, to hoofed animals, to the ungulates. And by going and taking that approach, we try to maintain the biology and don't upset it, because that's critically important. And then we go and we avoid, by going and how we make any of those lines through there, we put it back such that we avoid the human traffic going up and down them for all sorts of recreational purposes. So that's just a couple examples that I could share here and open it up.
I just want an additional point. We're on the same page. I think we all want to reduce emissions. The issue is, if you look at the reality of the consumption that we are forecasting and the population growth, the urbanization and the improvements in standard of living across the globe, people that don't have energy today, we're going to need a certain amount of energy. And the practicality of the situation is that means we're going to still need fossil fuels for some period of time. Would we all like to transition faster? Yes. It's a question of what's practical in the time frame.
Okay, I think that our time here is up. And so I think there's probably more conversation to be had about that question, so feel free to come up and talk with people. I really want to thank the panelists here. It's been a great discussion. I feel like I'm still on that roller coaster. Not sure what's around the next corner. The diversity of perspectives here, I think some think we're still going up, and some think we're on the verge of going down, and I believe this conversation will continue for the next few years. So thanks a lot for coming.